For this lesson, our focus standard comes from Grade 8, Geometry, Standard B, Understand and Apply the Pythagorean Theorem. Our topic for this lesson comes from Pythagorean Theorem in the Number System, More Practice with the Pythagorean Theorem. Our essential question for today is, how do we use the Pythagorean Theorem to find missing side lengths, A or B? Please take a moment, pausing the video if you need to copy down your standard, the topic, and essential question into your header, along with today's date, sub your question column, and your note column, and resume the video when you're ready to begin. So you may remember from our last video where we used the Pythagorean Theorem to find the missing hypotenuse, side C. What I want us to work on today is using our equation solving skills to go through the same formula, a squared plus b squared equals c squared, but this time find and solve for missing side lengths either A or B. So I have 3 examples for us today. Let's go ahead and get started with our first example. For all of these examples, as I said, we'll be finding the missing side lengths either A or B. So in problem number 1, we have our right triangle, which is the only type of triangle we can use the Pythagorean theorem for. And it's telling us that the hypotenuse, side C, is 10 units. The leg, B, is equal to 8 units, but we don't know what this vertical leg, A, is equal to. So we need to solve for A. So here I've laid out the Pythagorean theorem for us, a squared plus b squared equals c squared. And we're going to follow the same first step and plug in our values for b and c. So now, using our information from the problem, our equation reads a squared plus 8 squared equals 10 squared. So, just like before, solving exponents in our equations is always our first step, and so we have some work to simplify to find 8 squared and 10 squared. Go ahead and write out your next line. I would expect to see a squared plus 64 equals 100. But here we have a squared and 64 on the same side as the equation. So this is where we need to go back to our equation solving steps and try and get a squared by itself. So we need to make 64 a zero pair. So we're going to subtract 64 from both sides. This is going to cancel out. And we're going to be left with a squared equals 36. Because 100 minus 64 is 36. The positive and negative 64 canceled out. We brought down a squared. So now we're almost done, but what we know is that the area of the square built off of this side length has an area of 36, a squared. We just want to find out what the value a is. So to undo the square, a squared, we're going to take the square root of both sides. So can you determine what is the square root of 36? What number times itself twice equals 36? If you said a is equal to 6, I'd agree. So now let's take a look at the next problem. In problem number 2, we're looking at our right triangle. Although it is rotated, we still have one angle with a 90 degrees, so we're dealing with a right angle. We know that the hypotenuse, side C, is equal to 5 units. This leg A is equal to 3 units, but we don't know the value of B. So once again, we're going to use Pythagorean theorem, and we're going to substitute in the values we know for A and C. Go ahead and do that now, and begin to work through the problem. If you get stuck, you may want to pause the video now and work through the problem, but if you get stuck, resume the video and I'll walk you through. So if we plug in our values for a and c, our next line should read a squared, which is now 3 squared plus b squared equals 5 squared. Before we begin to solve for b, we want to simplify as much as possible, so we want to find what is the value of 3 squared and 5 squared. So our next line is going to be 9 plus b squared equals 25. Now that we're solving for b, or in the process of, we need to get b squared by itself. So we need to zero out 9. How are we going to do that? Well, we need to subtract 9 from both sides to zero this out and be able to bring down our b squared. 25 minus 9 is 16. So we know that b squared is equal to 16. As we show our work and solve this problem, we want to undo squaring a value, which means we're going to take the square root of both sides. What number multiplied by itself twice equals 16? What is the square root of 16? If you got the answer that b equals 4, you are correct. And now for our third and final problem. Here's another right triangle with all the information labeled. Go ahead and pause the video here, work through the problem, and then resume the video when you're ready to check your work with mine. Let's see how you did. So using the information from our diagram, I filled in the values for a and c. So I now have 7 squared plus b squared equals 14 squared. Then to begin to simplify the problem, I found the square of both 7 and 14. So the problem reads 49 plus the b squared equals 196. Now that it's simplified, I need to get b squared by itself, so I subtracted 49 from both sides. When I do that, I get the answer b squared is equal to 147, because 196 minus 49 equals 147. Now that I need to undo the square of b, I'm going to take the square root of both sides. And as I work through, I'm looking at 147, and it doesn't look like a perfect square, because I know that 12 squared is 144, and this is just 3 more than that. So I'm going to leave it in its radical form. b is equal to the square root of 147. I know that b is a decimal that is in between 12 and 13, because as I said, 12 squared is 144, and 13 squared is bigger than 147. So 147 is not a perfect square, and so we can leave our answer in a radical form, but we want to make sure we understand about what value we're expecting. So we know it's a decimal between 12 and 13, probably closer to 12, since 12 squared is only 3 away from 147. Alright, so that is going to conclude our video today. Please take a moment to make sure that your notes are complete and that you're understanding how we're combining our work for using the Pythagorean Theorem and our solving equation skills to now use it to solve for the legs of the right triangle. At this point, you should feel comfortable using the Pythagorean Theorem to solve for any of the 3 sides that may be missing on a right triangle.